Hello everyone. I'm Andy from ThinkMo. I'm teaching CCIE course now. Starting today, I will share with you some CCNA, CCNP, CCIE technologies. Our topic today is in OSPF network. Why can't the DR be preempted? First, let's get to know what is DR. It's called the designated router. Now let's get down to business. In the process, it is mainly associated with OSPF LSDB. LSAs in the link state database are related. OSPF has many LSAs procedure. This is mainly involved in indicates type 2 LSAs. So how does it relate to type 2 LSAs? First of all, for MA or NBMA environment, DR-BDR exists procedure. The DR is called the designated router. Type 2 LSAs are generated by it. For type 2 LSAs generated by DR, what information is being described? If we want to make sense of DR, why can't it be preempted? The first thing is to figure it out. Some of its properties. The LSA generated by it. What is the concept? It has information describing two parts. One is the topological information we mentioned. One is routing information. So in here, topology information and routing information. Based mainly on what? First type 2 LSA. This is what we refer to as the middle LSID. It is the IP address of the DR interface. Then there's netmask. This is what we call a netmask. So we go through the link state ID and the netmask. Do the AND operation to get the routing information. What's involved in this? Topology information and routing information. Just a quick mention. So let's draw a picture here. Two routers. Let's connect it. In the case of MA or NBMA, let's say it's DR. What it produces is the link state ID of its interface. Then it advertises its own netmask. In this case, it will send it to the entire OSPF network through some of the corresponding routers. Because of OSPF link state routing protocol, it will send LSAs in the LSDB. Synchronize the data to the whole network. Let's say it's now DR. It's in this router. We'll call it router 2. This is router 3. In this direction. Let's say I have router 1. In this direction. There is a router 4. There are a lot of routers connected down there. In this topology. Once the DR changes, which means that the router behind the DR, the routing information must be recalculated. Update the validation status database. In the link state entry protocol, it uses an algorithm called SPF. It's called acyclic based shaping algorithm. As we mentioned, MA and NBMA is actually a tree of SPF. So let's keep drawing it. Let's take a simple extension spectrum. The entire OSPF network. It's all based on SPF. It's called the tree algorithm. Like the branches of a tree. If this tree changes, the branches change too. It affects the whole body. This trunk is the equivalent of DR. It is the shared link we mentioned. DR changes. The value has to be recalculated. So once the DR is preempted, it will result in the number of SPF algorithms recalculation. The device performance deteriorates. In addition, the convergence speed of the network is reduced if you join. The router has a high frequency. Let's say I have some lines. Often up, down, out of order. It also leads to the whole. The OSPF network flaps. Procedure. So that's why. In an OSPF network environment, DR must not be preempted. This is also in some interviews. Topics that might be covered. So you can start with analyzes type 1 or type 2 LSAs. If you have a good knowledge of LSAs. Or OSPF topology information. Routing information. Description of various LSAs. If you know enough. So there's nothing wrong with that. That's all for today. If there are any other skills you would like to learn, feel free to leave a comment or send me a private message. If you're interested in what I'm talking about, hope to like and subscribe more. Thanks and see you next time.